Hello, this is Mr. Carlin. Let's talk about lesson 10-3, measures of center. Make sure you have pencil and a highlighter. Our I can statement says that I can use the measures of center to summarize a numerical data set with a single number and find a missing data value given the mean. Okay, let's talk about what measures of center are. Measures of center. The data set can contain many values, but sometimes it is beneficial to find a single value that can represent or summarize the entire data set. A measure of centers are numbers used to describe the center of a numerical data set. So that's a vocab term. Make sure you highlight that. The measures of center you will learn about in this lesson are mean and median. You've probably heard of those before. One measure of center used to describe the numerical set of data is called the mean, or the average. Okay, mean is an average of a data set. Okay, the average of a data set is the sum of the data divided by the number of data values. That is how we find the mean. Okay, so suppose you have 4 test scores. And you could probably do this with your test scores in IC if you wanted to find your overall average. But suppose you have 4 test scores, 86, 90, 72, and 88%. You can find the mean by adding the test scores and then dividing by the total number of scores of 4. Okay, we had 1, 2, 3, and 4 different test scores. So we'll add all of those together and then divide that answer by 4, and we end up with an average or a mean of 84. So if these were your test scores, you could say that your average on your test all year was 84%, which would be pretty good. That's like a B average. All right. Let's turn the page. It says the mean is a balance point of the data. Okay, it's a center of all the data. The dot plot displays the test scores. The total distance between the values below the mean and the mean must be equal to the total distance between the values above the mean and the mean. Okay. So here in this dot plot, okay, we have a data point of 72, a data point of 86, 88, and 90. These are our test scores. Okay. If we add all of these together, okay, that's where we ended up, where we added and divided, and we ended up with 84. Okay. But the balance point is the center, or the mean, of 84. It's not a data point, it's a center. Okay. Now, every point has a distance from the mean. 86 was 2 above the mean. 88 was 4 above the mean. And 90 was 6 above the mean, with 72 being 12 below the mean. Okay, so every data point has a distance of those values. Okay. All right. So what they were showing in this one is that all the ones that are above, if you added that together, 2, 4, and 6, you end up with 12, which is the same as the lowest. Okay. So it's the middle point. All right, example 1, how to find the mean. The table shows the recorded high temperatures in degrees Fahrenheit for 6 days in Little Rock, Arkansas. We need to find the mean temperature to summarize the data. So here's all of our temperatures for an entire, or I guess it'd be Monday through Saturday. They don't have Sunday on there. So we have 45, 52, 45, 50, 49, and 47. So to find the mean, we're going to add all the value points together, and then we're going to divide by how many we added together. So we're going to add all of those together and divide by 6. When we add them all together, we got 288, and we divided by 6 because it's 1, 2, 3, 4, 5, 6. So we ended up with an average of 48, or a mean of 48 degrees. So the mean temperature of the selected days is 48. Get my book moved here. There we go. The dot plot confirms that the mean temperature of 48 is the balance point of the data. The total distance between the values above the mean and the mean is 7, is equal to the total distance between the values below the mean and the mean. Okay, so 48 is our middle point. 49, the data point of 49 from Friday is 1, which is 1 above, 50, which was 2 above, and 52, which was 4 above. If you add those together, you get 7 above the mean. The ones below, you get 1, 3, and 3. Add those together, you get 7, so they should equal each other to know that this is a balance point, 7 on each side of the mean. Okay? All right. I want you to do this check question. Pause your video, do the check question, then come back and check your work. Make sure you read it carefully. All right, now that you've done it, let's check it. It says the table shows the number of headphones sold at an electronics store during a sale. Find the mean number of headphones sold to summarize the data. Okay, so to find the mean, remember we're going to add all of these together and then divide by how many we added together. Okay, so when we add them all together, we're going to do 9. We're going to do 9 plus 18 plus 7 plus 7 plus 10 plus 15, and we're going to divide that by how many data points? 1, 2, 3, 4, 5, 6. Okay, and I'm going to get my calculator. You should have already done this in Desmos, but I'm going to get my calculator out here. And so we got 9 plus 18 plus 7 plus 7 plus 10 plus 15. So we got a total of 66 divided by 6. So we should have an average or a mean of 11. Okay, and that means that they sold an average of 11 headphones over 6 days. Okay, let's look at how to find a missing data value using the mean. You can use dot plots and bar diagrams to find missing data value given the mean and the other data values. So consider the following problem. Caitlin's first 4 quiz scores are shown in this table. What score does Caitlin need to earn on her 5th quiz to have a mean score of 90? Okay. So one way of looking at this is to balance it using a dot plot. Okay. We're going to plot the 4 known quiz scores and label the mean. So on our dot plot, we'll plot 80, 88, 93, and 95. And then we're going to show our balance point of 90 for the mean. Now, the distance below the mean is 10 plus 2, which is 12. And the distance above the mean 5 plus 3, which is 8. So we know we need to have a data point on this side to balance it out because 8 is smaller than 12. So the distances are not the same because the 5th quiz score is not plotted. So we have to decide, okay, how many more up do we need to count? Well, you go from 8 to 12, how many more do you need to count? 4. So your data value needs to be 4 more than the mean. So what it would be 4 more than 90? 94. So we should have a missing data value, or she needs to score at least a 94% on her next quiz score to have an average of 90, or an A average. Okay. That was easy, I hope. Let's look at method 2, how to use an equation. Okay, so draw a bar diagram to represent the situation to find the total amount needed to achieve the mean score of 90. So we're going to multiply the mean by 90 by the number of data values, which is 5. So we're going to take our mean, which is 90, and we're supposed to have 5 data values, and that has to equal 450. So the sum of the known data values, 1, 2, 3, 4, 5, okay, the sum of those known data values is 356. Okay, and we're going to let Q represent the score of her fifth score. So when you add all of these together, you end up with 356. So in their bar diagram, this is your 88 plus 95 plus 93 plus 80, and then we're going to have that additional score of Q that we don't know, and those all have to total up to be 450. Okay? The 450 came from this, to where our average was multiplied by 5 data points to get 450. And we only have 4 data points that we know, with one of them we don't know. So the equation can be used to find the missing data value in 365 plus Q to equal 450. So we're going to solve that equation. 356 plus Q equals 450. If I'm adding, that means I'm going to subtract. So I'm going to take away 356 from both sides, and that leaves me with Q to equal 94. So the missing data value is 94, okay, or 94%. So she needs to score 94% on her 5th quiz to get a score of 90. Okay. Let's see. All right. So this one, in example 2, it says find the missing data value using the mean. The number of messages Alex sent on her phone each month for the past 5 months was 494, 502, 486, 690, and 778. Suppose the mean for the 6 months was 532 messages. How many messages did Alex send during the 6th month? Okay, so we know that for 6 months we have a mean of this, or an average of this. So we can use a dot plot. Okay, I kind of like this one better than I like doing the equation, but if you like doing the equation better, that's fine too. So we're going to go ahead and plot all 5 points on the mean. So we plot those points, then we have our mean, we find our distance, so we total up these distances. That's where it does this on the next page over here. Totals up those distances, so when you add all of those together, let me make sure I'm on the right one here. Yeah, you get 168. Notice we're going to have a difference, okay, of 10. Okay, we have more that's below the mean, 10 more, and so that means we need to add 10 more to this side. So that means our next data value needs to be 10 more than the mean, so 532 plus 10, or we would say 542. Okay. Now if you use the equation method for this one, the equation method works well when you have smaller or bigger numbers and you don't have space to plot everything out. Okay. So to find the total amount needed for the mean number of messages, okay, to be 532, we're going to multiply the mean by the number of data values. So we should have 6 data values. So we do 532 times 6, which is 3,192. And then the sum of the known data values, when we add all of those up, we end up with 2,650. Okay, so this is our known, this is what we don't know. So that means we're going to take this known and we're going to add it to m, what we don't know, to get a total of 3,192. Then we would solve it from that equation. So 2,650 plus m to equal 3,192, and we solve that. If I'm adding, then I'm going to subtract. Okay, and when I subtract those, I end up with 542. So the missing data value is 542. Okay, so either method works. Again, I like the dot plot better because you can visually see when it's not balanced, okay? But an equation could be a little bit faster and work better with larger numbers, okay? All right, let's see. We're gonna actually, let me look here, make sure, right one here. Let's skip this check question, I know, you're welcome. And let's go ahead and go to find the median, okay? All right, another measure of center to describe numerical data set is the median. The median of a numerical data set is the middle value when the data is ordered from least to greatest, okay? So highlight this part, that median, okay, is when it's in order from least to greatest. I always like to say, hey, diddle diddle, median in the middle, okay? Median's always in the middle, but it's got to be in order from least to greatest. If there's an odd number of the data values, then the median is the middle data value. If there is an even number of data values, the median is the mean of those two values in the middle, or the average of those two values. So let's look at that. So let's look at this set of numbers here. Consider this numerical set of data, which represents the ages of participants in a board game club. Okay, so we have all of this, okay? There are 13 data values, so it's an odd number. Since the number of the data values is odd, the median is the middle data value. Make sure the data values are ordered from least to greatest. I don't know how much more I can stress that, and you might want to just go ahead and highlight that, but you always got to put the numbers in order from least to greatest, okay, before we do anything, okay? So sometimes what I like to do when I have my data set is I'll take my fingers like this, okay, and I'll cover up each time I go, okay, until I get to the middle. Whoops, hang on. Did I cover up too many? Yeah. So 1, then 2, then 3, then 4, then 5, then 6. So I end up with one number in the middle. So my median is 10 in this set. Okay. Notice we have 6 on this side and 6 on this side. Okay. All right. Next example, example 3, it says find the median given an odd number of data values. So between 2009 and 2015, the number of Atlantic hurricanes each year was 3, 12, 7, 10, 2, 6, and 4. We're going to find the median of this data set. Notice, are these in order from least to greatest? No, they're not. So what do we need to do? Put them in order from least to greatest, and that's step 1 right here. Okay, so we're going to start with 2, and then 4, and then, oh, I messed up. I missed the 3. So 2, then 3, then 4, then what? 6, and then 7, and then 10, and 12. Okay, now to find the median. So step 2, how many data values are below the median? Okay, so our median is the middle. So below, it looks like 1, 2, 3, and then 1, 2, 3. So we're going to have 3 that are below and 3 that are above. And so our middle value is 6. Okay, what I like to do, cover up one at a time until I'm left with the number in the middle. Now, what happens if I end up with 2 numbers in the middle? We're going to talk about that here in a second. Okay, but not yet. Okay, so the center of the data can be represented by a single value of 6. So the median number of hurricanes from 2009 to 2015 is 6. Okay, that's quite a few hurricanes in a year. Okay. All right, so let's do this check question. I want you to read it, pause the video, read it, and then unpause your video and check your work. All right, now that you've done that question, let's go do this question. It says Diane's scores on a recent science test were 86, 98, 85, 90, 85, 91, 89, 88, and 89. Okay, we need to find the median. What is the first thing we do when we're finding the median? Raise your hand. I'm just kidding. I'm in a video. How can you raise your hand and I answer you? The first thing you should do is put them in order from least to greatest. All right. So what is the lowest number we have? So let's see here. We got an 85, 85. Looks like 85. I actually had two of them. I like to cross them out. So I'm going to write down both of them. Okay, then we had an 86. Nothing in between there, so 86. Okay, anything else in the 80s? 89, 88, 89. Okay, so we have an 88, an 89, and an 89. So we got to put both of them. And then 90, 91. 90, 91, and because I crossed them out, I can see, oh yeah, 98. Okay, so now we need to find the middle. Okay, I'll take my fingers. That's what I like to do, just cover up on the ends one at a time. So 89, and let's check that. So I got 1, 2, 3, 4, 1, 2, 3, 4. So 89 is my median. All right, easy. Hey diddle diddle, median in the middle. All right. So let's see what would happen if we have an even number of data values. Okay, it's not much different other than we end up with two values in the middle when we take our fingers and go across. Okay. All right. So here in this table we've got our data. Okay, looks like it's a number of monkeys at 10 different zoos, or number of monkeys in a classroom. Wait, no, zoos. Oh wait, school, zoo. No, just kidding. Okay. So we need to find the median. There are 10 data values. Because the number of data values is even, the median is the mean or average of the two middle data values. So again, first thing we do, put them in order from least to greatest. So we put them in order, least to greatest. Then we find the median. Okay? So let's look when they go to do that, and since it's a sentence is like that, so it's going to be cover and cover and cover and then cover. So I end up with 25 and 27 in the middle. Okay, so the two values in the middle are 25 and 27. So to find the middle of that, well, I mean, you could almost look at that and be like, well, what's between 25 and 27? If you said 26, you're right. Okay, and the way to prove that is to do 25 plus 27 divided by 2. 25 plus 27 is 52. Divide that by 2 and we end up with 26. Does that make sense that it should be 26? Yes. So the median is 26. Okay, and there's 26 monkeys. Okay. All right. Do this check question down here at the bottom. Pause your video, then unpause it and check your work. All right, let's try this one. We're going to put these in order from least to greatest if we're finding the median. Okay, so we start with the smallest, so looks like it's going to be this one, 1.65. Cross it out. And then 197, 1.97, and then it goes to 2, so 235, 245, 287, 280. Okay, so it's going to be the 235, then the 245, okay, then 249, almost missed that one. Then 287, 287, so two of those. And then 375. 375. All right. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh wait, 1, 2, 3, 4, 5, 6, 7, 8. 8. So that means we're going to have two values in the middle. So cover up on the ends. So I end up with 245 and 249. So what we're going to do is 245 plus 249 divided by 2. We'll get our calculator out. Okay. 2.45 plus, what did we say, 2.49, and then divide that by 2. So we get a mean of 247 for a median. Okay, median. All right. Let's go ahead, and I think that would be good enough for this. I want you guys to do the practice problems on page 559. Okay, 1 through 8. All right, if you got any questions, be sure to ask your teacher and check your work with your teacher when you're done. Thank you.